Alright, the second half of the objective of solving quadratic equations by using the MACAB T-chart involves quadratic equations where the A term is not 1, if you notice right here. So this is the difference between the video you just watched and this video you're about to watch. It's still the same thing. You use this technique, the MACAB T-chart, when all the terms A, B, and C are present, but the only difference is when the A term is not 1. If you notice in this case, the A is 5. From the previous objective, the A term was 1. If you notice here, it is 1. And so it's the same. You're going to use the MACAB T-chart, but there's a couple different steps you have to do when the A term is not 1. So just keep that in mind. It's very similar to the previous objective, but I had to switch it up, or I had to separate them to show you how they are different. Now, this process is this is probably the hardest factoring you'll do out of all the techniques, all right? Because it is a little bit more in depth, especially when you get down to step 3. So just be aware of that when you're watching this video. Now, if I'm given 22 as a problem I'm going to do, I would notice that 5p squared minus 12p plus 7 equals 0. For one, I'd notice two things. For one, I would use this technique, the MACAB T-chart, because indeed all of the A, the B, and the C term are present. So whenever that's the case, I use MACAB T-chart, no matter if the A is 1 or not 1. So that's my first thought. I'm going to use the MACAB T-chart strategy for factoring, okay, because they're all present. The second thing I would notice, though, is that the A term is not 1, so that's going to clue me on how to do, I have to do step 3 here eventually, which is a little different than the previous objective. And then finally, step 1 says get into standard form with the right side equal to 0. If I look at this, it's already in standard form. The right side equals 0, and if you remember, the standard form is ax squared plus bx plus c equals 0. It's already in that form. I have my ap squared minus 12p plus c. It's already in that form. So I don't have to do step 1. It's done for me. Now, there will be some in your homework where that's not the case, and you'll have to do step 1, all right? You have to move things around to get it into standard form. But in this case, it's already done for me. So I can jump right to, I'm going to put step 1 is already done. I'm going to jump right to step 2 then. I'm going to use the MACAB T-chart to find my factors. It's the same process. I'm going to write Mac and AB. Now, a little difference though, if you notice, Mac stands for you multiply the A and C terms together, but this case A is 5 and C is 7, so 5 times 7 is 35. It's a little different because usually when A is 1, it just becomes the C term, but A is not 1 here, so 35, and then AB, or AB, is always just the B term of negative 12 in this case. Now, MAC stands for, I need to find two numbers that multiply to the A and C terms, so in this case I need to find two numbers that multiply to 35, and that add to negative 12, alright? I'm just going to go down the line. You can use that calculator trick of putting the MAC term 35 divided by x into the y equals, and then hit table, and it'll bring you up a list of factors. I'm just going to show you my thought process if I didn't use the calculator again. Now, I always start with 1 and its partner of 35. 1 times 35 is 35, but no combination, positive or negative, of those two numbers would add up to negative 12. And then I go down the line. After 1 is 2. 35 divided by 2 is not a whole number, so 2 isn't a factor. Then 3, 35 divided by 3 is not a whole number, so 3 isn't a factor. Same story for 4. 35 divided by 4, not a whole number. Now I arrive at 5. 35 divided by 5 is 7, all right? So 5 times 7 is 35. So 5 and 7 are factors of 35. Now my second step is I have to see, do they add up to negative 12? In this case, 5 plus 7 equal positive 12, right? So that doesn't work, but I still know that these are the numbers I get to work with, and I feel like they're going to give me the correct answer. I just have to make something negative, all right? Now if they multiply to the MAC term but don't add to the B term, then my next thought process, and yours should be too, is can I make one of them negative or both of them negative to make the entire puzzle fit? All right, so I'm going to do then, let's start with negative 5. and positive 7. Now this situation doesn't work at all because negative 5 times 7 is a negative 35. So that doesn't satisfy my original Mac term. And same thing with 5 and negative 7. It multiplies to a negative 35, so that doesn't work. So in that case, I have to make both of them negative. So a negative 5, comma, negative 7. If you notice, I'm going to extend that. If you notice, negative 5 times negative 7 is a positive 35, and negative 5 plus negative 7 is a negative 12. So I have found the pieces of the puzzle. I have determined the factors, and they are negative 5 and negative 7, and they add up to negative 12. So I'm done with step 2. That process, step 2, can be a bit frustrating. Please don't get discouraged when you're working through that. Sometimes it's just some guess and check work along the lines of what I just did. Okay. Now, step 3 looks a little different. I said write in factor form. Technically, it's still standard form, and I'm going to write in standard form, but I'm going to split up the b term. Okay. So if you notice, my b term is negative 12. This is step 3. I'm going to draw a separation line. My b term is right now negative 12. Okay, so I'm going to split up that b term into my new factors. But first, in standard form, I have to write 5p squared. I just drop down the 5p squared. Now, negative 12 separates, I'll do this in a different color. I'm going to separate negative 12 into my two new factors. So negative 12p becomes a negative 5p and a negative 7p. So if you notice, it separates into those. All right? And then finally, I drop down my 7, because I didn't touch that either, and I just do plus 7. So at this step, step 3, you should have 4 terms. All right? That's how you should check your work. There should be 4 terms now, because I split up my b terms. So I have 1, 2, 3, 4 terms. So I'm done with step 3. All right? I split the b term up into my factors that I found. Now, step 4 is you find the greatest common factor of each binomial. All right? So in step 4, I'll switch to this color. Step 4, I'm going to do what's called, you group them first. All right? So I'm going to group the first 2 together and the second 2 together. So if I group the first 2 are 5p, the first 2 terms, I'm sorry, so 5p squared minus 5p. That's the first grouping. All right, I just put parentheses around the first 2 up here. The second grouping, I'm going to include this sign. All right, that sign is a negative, so I'm going to include the negative. So I'm going to write minus 7p plus 7 still equals 0. All right, that's the first step. I've grouped the first 2 together and the second 2 together, and I included the negative in my second grouping, right, or the subtraction sign on my second grouping. Now it says to take the GCF from each binomial. So the GCF, and this is why you have to call upon previous knowledge of how to find the greatest common factor. So I'm not going to show you how I did that. I'm just going to show you the math that exists for finding the GCF. Still within step 4, the GCF of 5p squared and 5p is a 5 and a p, right? The number that goes into 5 is 5. The greatest number that goes into 5 is 5. And the biggest value of p that I can factor out is just one of them. All right, so 5p, and then I'm going to write what remains after I divide the GCF from both. 5p squared divided by 5p, 5 divided by 5 is 1. P squared divided by p is just p. All right. Then I move on to negative 5p. So negative 5p divided by my GCF. Negative 5 divided by 5 is negative 1. And then p divided by p, they cancel out. So I'm done GCFing the first binomial. Now, I need to GCF the second binomial. Whenever this exists, this situation, okay, so please listen to this. Whenever it is a negative first term right here, I need to write, I'm going to factor out a negative, okay? Whenever it is a negative, I factor out the negative. In this case, then, the GCF from between 7 and 7 is 7. So I factor out the negative 7. I cannot take a p out because this term doesn't have a p. So the GCF of this binomial, negative 7p plus 7, is just negative 7. Now, when I divide out a negative 7 from each term, negative 7p divided by negative 7, the negative 7's cancel out and it becomes a positive p, because a negative divided by a negative turns positive. I can show that work, negative 7p divided by negative 7. The 7's cancel out and the negatives cancel out, and I'm just left with p. Alright, and then 7 divided by negative 7 equals a negative 1. So minus 1. And I am done, alright? At this step, the way to check yourself at the end of step 4, so please listen to this too, is that the second, or the groupings of binomials that you have are the same exact thing. If you notice, they are the same. I have a p minus 1 over here, and I have a p minus 1 over there. Alright, so that means I did step 4 correctly, and I can move on to to finish step 4. I'm sorry, step 4 is super extensive. Now, to finish step 4, I'm going to regroup things, okay? So, the similarity, or the same thing, p minus 1, comes out. And technically, I'm taking the GCF of this entire thing, and in this case, the GCF is p minus 1, but sometimes that confuses people. So what I'm really doing is I'm grouping these two together, and they become 1, p minus 1, in one parenthesis, and then I write the remaining pieces that aren't together yet. I put them in their own parenthesis as well, and technically, I'm pulling out the GCF p minus 1, and what remains when I divide each term is 5p minus 7 in this case. Alright, and that equals 0. At this point, this is the trickiest part, but all I did again was I pulled out the greatest common factor of p minus 1, and when I divide each term by it, I'm only left with a 5p and a negative 7. At this point, I am done with step 4. Alright? Step 4 is probably the trickiest part, and it'll be this part that you will struggle through potentially right away, but you'll get the hang of it if you keep working at it. At this point now, it's the same thing as always. I use the zero product property because if you notice, I have two factors now in parentheses. So my first factor, I'll switch colors, p minus 1, this is step 5, p minus 1 equals 0, and 5p minus 7 equals 0. That is the zero product property. You just set each factor equal to 0, and now I'm going to solve for the variable. So, I add 1 here, add 1, p equals a positive 1 here. I add 7 to both sides, so now I have 5p equals 7, divide by 5, and cancels out here. I have p equals 7 over 5, or 7/5. I have found my two solutions to this original quadratic function of 5p squared minus 12p plus 7. When you master this, you should feel very proud of yourself because there is a lot of work that goes into these steps, and you do have to take it step by step, and step 4 might be the trickiest of all of them. But that is the process, and I have found the two solutions, p equals 1 and p equals 7/5. Please pause the video and try number 21 on your own. Check your steps with mine when you're done to check your understanding. At this point, you should have paused this video and tried this example number 21 on your own. Alright, so if you notice, it's already in standard form. I didn't have to do step 1. Step 2 is the MACAP T-chart. I showed 1 through 6. I've tried the number. I've divided 42 by 1 through 6, and I found that 6 and 7 are the factors. Step 3, I split up the b term into my factors. Step 4, I grouped them, the first two and the second two. Step 5, continuation of step 4, I found the GCF of each term, n and 1. And in this case, there was technically no GCF, but in that case, you just pull out a 1 because it still needs to be grouped. It still needs to have two pieces down here. And if you notice, when I do that, these are the same. And then I re-GCF'd it, I set it each equal to 0, and then I solve both. And so these are my solutions. N equals negative 6 over 7, and n equals negative 1. If you did not get this, please raise your hand because this is a tough topic. and we can come over and talk about it.